place where NASA completes the final assembly of its rockets before launch. The sheer scale of this building is hard to grasp, even when you're right next to it.
Do you ever feel really small when you think about space? What about when you're standing next to a skyscraper or a really big bridge? Well, I feel about as small as an ant right now. I'm standing inside the vehicle assembly building trying to grasp how large it really is in here. It has 4 bays. Each bay has 2 large horizontal doors below it and 7 smaller vertically opening doors above it, tall enough to fit the world's largest rocket through. In fact, these are the largest doors in the world.
Construction of the VAB required 65,000 cubic yards of concrete, 45,000 steel beams, 1 million steel bolts amounting to almost 100,000 tons of steel. Notice the flag painted on the outside of the VAB? It's the size of a 21-story building. The blue section alone is the size of an NBA basketball court. Each star is 6 feet across, and each red and white stripe is wide enough for this bus to drive down. And the entire VAB? It's so huge that the Roman Colosseum would fit on the roof with room to spare for a parking lot. By volume, the VAB can fit 3.5 Empire State Buildings, and it would take 250 billion ping pong balls to fill it. It was built in the 1960s for the Apollo program. Every Saturn V rocket that sent humans to the moon was assembled right here. Every space shuttle mission also assembled within these same walls. After the space shuttle program, a major renovation to the inside of this building began to accommodate NASA's next generation of rockets, the Space Launch System, or SLS.
NASA is known for dreaming big, and big dreams require big equipment. I'm standing next to the Crawler Transporter, the largest self-powered land.
Now, if you look over at the vehicle assemble building, the gray doors, they are 456 feet tall, and they take 45 minutes to completely open or close.
Vehicle in the world. It was originally built in 1965 for the Apollo program, and has since been updated to accommodate the space shuttle and now NASA's SLS rocket. Weighing in at 6 million pounds and capable.
When we cross the intersection on your right, if you look all the way to your right there, you'll see Crawler 1. Crawler 2 is now being used to transport the SLS rocket to Launch Pad 39B.
Of lifting and hauling 18 million pounds. The Crawler is an engineering marvel, even without a rocket sitting on top of it. This thing has 2,750 horsepower V16 diesel engines that can carry the Crawler up to a top speed of, wait for it, 1 mile per hour while carrying a rocket. Keep an eye out for the Crawler as we approach this area. And remember, we are visiting a working spaceport, so while the Crawler may not stay in one area for very long, it's bound to be out here somewhere. Now, let me introduce you to my friend, John Giles, the Crawler project manager.
I'm standing in front of Crawler Transporter number 2 at the Kennedy Space Center. Crawler Transporter 2 is used for the SLS program to take the launch vehicle back and forth to the pad. To move the rocket from the vehicle assembly building, or the VAB as we call it, to the launch pad, a certified operator carefully maneuvers the Crawler underneath the mobile launcher where the SLS is stacked. We then pick up the mobile launcher and the SLS rocket together and slowly, very slowly, carry it to the launch pad. It's a 4.2 mile trip that takes 7 to 8 hours. We'll roll over a specifically prepared crawler weight that consists of river rock, anywhere from 8 to 12 inches thick. Below that is limestone that's 4 to 5 feet thick that is hydraulically compressed, and then below that is another 20 to 30 feet of sand which supports the weight of the crawler and the mobile launcher as we roll over top of it. Once we're at the launch pad, we drop off the mobile launcher and the SLS rocket. And after the launch, we come back, pick up the mobile launcher with the crawler again, and bring it back to the VAB. Then we'll repeat this process for the next Artemis mission.
With 50 years and some 3,000 kilometers or 2,000 miles on the clock. NASA expects the crawlers to be in operation for at least another 3 decades. How cool is that? The crawler will be doing what it was originally designed to do once again, which is moving rockets.
And hopefully, I think it's supposed to launch sometime in February. We'll see how that goes. And once again,
This is the firing room, launch control for the Apollo mission. This is not a mock-up. These are the very consoles we sat at when men first took off the flight to the moon. The tragedy of Apollo 1 put us a year and a half behind. We were making up for it in one big leap. And we were doing it with a rocket that no man had ever flown before. It was a few days before Christmas, 1968, when Apollo 8 sat on the pad. She was the first of a new kind, a moon rocket. This was the Phoenix, risen from the ashes of Apollo 1. The first Apollo crew did not die in vain. This was to be their testimony. Stories high, she had been fully fueled throughout the night. The liquid oxygen in her tanks caused ice to form on the outside of the craft. The extreme temperature differences between the air and the sub-zero fuel caused the metal skin of the rocket to expand and contract. Everyone who was on the pad agreed. It was as though the rocket was alive, breathing, straining at the leash. Earlier in the morning, astronauts Frank Borman, Jim Lovell, and Bill Anders had made their final preparations before taking that long ride out to the waiting spacecraft. The minimum safe distance from a Saturn V at liftoff was 3 miles. The reason was simple. When fully fueled, the rocket contained the explosive power of an atomic bomb. As the clock counted down, the astronauts and all of us in launch control went through the pre-flight checks, our hands on the controls of the most powerful, most complex machine ever built. It had over 2 million separate systems, and to bring these men back alive, everything had to work perfectly. Each individual system had been tested, but what we didn't know was how they would perform when all 2 million began to work together. That moment would come when the countdown clock reached 0. If a maneuvering thruster failed, if communications broke down, if navigation was off by 1 degree, if any piece of the miles of wiring, circuits, relays, or valves was defective, Frank Borman, Jim Lovell, and Bill Anders would pay with their lives. As they sat, waiting for launch on that chill December morning, these 3 astronauts were back to what they had always been, test pilots. You are now in the final minutes before the launch of Apollo 8, right here where it actually happened. Mankind is about to leave his planet behind and journey to another. It is one of those rare moments when history is not being made, destiny is being embraced.
We've completed our communications checks with the Apollo 8 astronauts in the cabin, and the communications are go. During this period, and once we do get the firing command, the various tanks within the 3 stages of the Saturn V launch vehicle begin to pressurize. We have firing command. The firing command is in. We're now on the automatic sequence. 2 minutes, 20 seconds, and count. Our status board indicates that all aspects are ready. Instrument unit is ready. Spacecraft ready. Final check of the emergency detection system. That ready light also on. First stage preparations are completed.
All systems are okay. Ron, ready to go to contact. And my word. Okay, you're on. All systems go.
1 minute, 45 seconds and counting. The first stage liquid oxygen tank has been pressurized, and the pressure is still building up. Coming up on 90 seconds, mark, T-minus 90 seconds and counting. The Apollo 8 crew standing by, spacecraft commander Frank Borman, Jim Lover, Bill Anders. We now have a report that the liquid hydrogen tank in the third stage is pressurized. 1 minute, 15 seconds. All third stage propellants pressurized at this time as we come up on the 60-second mark on the flight to the moon. T-minus 60 seconds and counting. The vehicle now is completely pressurized. We're coming up on a power transfer shortly. We have the power transfer. We're now on the flight batteries within the launch vehicle. Final reports coming from Frank Borman at this time. Final look at the switch list aboard the spacecraft. 20 seconds, all aspects. We are still to go at this time. 15, 14, 13, 12, 11, 10, 9. We have the ignition sequence start. The engines are on. 4, 3.
Apollo 8 successfully orbited the moon, and the astronauts returned safely to the Earth. I know. I'm Jim Lovell, and I was one of the crew of this spacecraft, Apollo 8. We were the first men to see the surface of the moon from just a few miles away. But it was the hundreds of thousands of men and women who worked on that team, and the millions of people who supported the mission that really made it possible. That way, I guess, we all went to the moon. the other side of those doors, you'll find an actual sapphire moonlight. It's still the most powerful, the most complex machine ever built. And I guess it's the only one that can take you to another planet. I actually got to fly one on a second flight to the moon called Apollo 13. But that's another story.
Continue your journey of the lunar beacon, located near the Los Angeles 7 rocket. Enjoy your visit to the Apollo